Well, good afternoon or good evening, ladies and gentlemen. I'm going to be going over the first part of your test review. So let's take a look here. Question number 1. List the equations needed to do the following. Molarity, I like the MVP, the molarity triangle. Molarity M equals moles over liters. But if you don't like that, you can say molarity is moles over liters. For the dilutions, that's when you have the starting molarity times the starting volume will be equal to the new molarity times the new volume. This is what we did in the Kool-Aid lab. Let's see, percent by mass, percent by volume. So the percent is going to be, you've got solute, either grams or milliliters, depending upon whether we're doing by mass or by volume, over the amount of solution, grams or milliliters. And you've got to remember, times 100%. You've got to remember this one right here. The solution is going to be solvent plus, that's in grams or milliliters, plus the amount of solute, either in grams or milliliters. So you just got to make sure, is the problem giving you the total solution, or are you going to need to add the two up? Number 2, let's see. It's asking you to rearrange the molarity equation in order to solve for number of moles. Okay, molarity, capital M, equals moles over liter. And you can multiply both sides by L, which is going to be liters times molarity, make that a very definite capital M, equals the number of moles. I highly recommend on your summary page you have the triangle for this. What's nice with the equation triangle, if you're looking for moles, you cover that up and it tells you it's molarity times liters. If you're looking for the volume in liters, it's going to be the number of moles divided by molarity. And then if you're looking for molarity, it's moles over liters. So let's see, let me adjust this a little bit. Number 3. What's the maximum amount of salt that can dissolve in 300 grams of water? Now they're telling you, you can either look that up, sometimes you may have to look on the solubility chart, but this one they're telling you. They're saying you can have 36 grams of salt divided into 100 grams of water, because this solubility chart is always based upon dissolving it in 100 grams of water. So we're going to make a proportion for this problem. So you can say, okay, this is what the solubility is in 100 grams. We want to know what it would be in 300 grams of water, so you can just make that x over 300. So at this point now, you just got to solve for x using your algebra skills. I'm not going to do that for you. Number 5, let's see, describe the following types of solutions. So saturated, that means you can't add more solute and have it dissolve. If you were to add more solute, more salt to a saturated solution, you would get crystals beginning to fall out. It would just fall right through. An unsaturated solution, that's a solution where you can still add more solute. You can add more salt. You can add more sugar, and it will dissolve. Once you get to the point that any more solute added just falls right to the bottom of the container and doesn't dissolve, then you become a saturated solution because you can't add more. Let's see, number 7. What generally happens to the solubility as the temperature increases? Well, you can take a look at a chart. For solids, on this chart right here, we can see this is the solubility in grams per 100 milliliters. This is the temperature, with the exception of gases. So when we're talking solids like salts, the more heat, the higher this chart goes. We've got a positive slope. Some of them are very positive, like this one. Other one's a little flatter. But the more heat, the more you can dissolve. So what happens to solubility as temperature increases? Solubility also increases, except for gases. And we did the Alka-Seltzer lab, and you found out when you plotted your graph, it looked something like this. It was a negative slope. The hotter it got, the less grams it held. Number 9, moving right along here. What is the molarity? Oh, let me turn on the lights here. They went dark on me. There we go. Got it. Okay. What's the molarity of a solution that has 8 moles? Now, the equation for molarity is capital M equals moles over liters. So we've got 8 moles here. And they're telling us 4 liters. We don't have to convert anything. You can do the math there yourself. Number 11. How would you rearrange a molarity equation to solve for number of moles of solute? Well, you know what? You know what? Gotcha. I got to go back. I did number 2 wrong. I'm sorry about that. For this equation here, the molarity equation is like this. We'll fix number 2 there in a moment. Moles per liter. So we're going to rearrange this. You have to multiply both sides by L, and you got number of moles. And that's how you rearrange it for moles of solute. I got to go back to number 2. I'm sorry. I read the question too fast. This question was asking us to solve for volume. So we're solving for volume. We're solving for liters right there. So sorry about that. Let me cross off what we did there. So molarity is moles over liters. To do it algebraically, you'd have to multiply both sides by L. It cancels out here. Then you're going to need to divide both sides by capital M. It'll cancel out there. And it turns out that liters will equal the number of moles over the molarity. And using the equation triangle, if you cover up liters, there you go. Sorry about that mistake before. Number 12. What's the molarity? Okay, so we're looking for molarity is moles over liters of 8 moles of solute. Okay, we got 8 moles. That's easy. Over 600 milliliters of solution. Well, that's going to be 0.6 liters. So there you go. 8 divided by 0.6 liters. You can get what the molarity is. Do your own calculations. Number 13. What's the molarity? Okay, so molarity is moles over liters. That's the equation we're going to need. And it says the molarity if you have 300 milliliters of solution in which you have 3 moles. Okay, pretty easy. 3 moles over 0.3 liters because you got to change 300 milliliters into liters. Done with that one. You can do your own math. What's the number of moles of solute and if you have 500 milliliters, I'm going to make that 0.5 liters right now. And we know the molarity here. So we're looking for moles. Well, from a previous problem, we know that, let's see, number of moles from question 11 is going to be liters times molarity. So moles are going to equal the liters times molarity, and that's what you did in the Kool-Aid lab, the first step. And in this problem, we've got 0.5 liters times the molarity of the solution is 0.5 molar. And then you can do the math, and you'll end up with your own answer there for that one. Number 15. Let me get the number there. What is the molarity of a solution that has 75 grams? So now we're doing molarity equals moles over liters still, but we've got a little hitch. You're going to have to change this into moles before we can do the rest of the equation. Now what's nice is the problem goes on to tell us that the molar mass is 58, so I can tell you that's probably salt. So we got to do 75 grams of solute. We've got to divide it by 1. We're just setting that up as that's our given in the problem. This is just doing stoichiometry. And then the molar mass is 58 grams. We want the grams to cancel out, so we need to put the 58 with the grams there is 1 mole. So now at this point with your calculators, you'll do 75 divided by 58. And then whatever that answer is, now we're going to divide it. So we're going to divide, I'm just going to put divided by Now we need to divide that by 800 milliliters becomes 0.8 liters. So do 75 divided by 58. It looks like to me it's going to be around 1.5. I'm just guesstimating. Whoop, there's the bell. And then we got to divide it by 0.8. You can do the math there. Number 18. How many milliliters are of a 2 molar solution of the salt are needed to make 300 milliliters of this one? So this is going to be volume 2. This is going to be a M1V1. This is molarity 2 because it's the lower dilution. This is going to be molarity 1 because it's a higher concentration. And we want to find volume 1 over here. Oh, I better zoom out a little bit. It's when I labeled the problem over here. So 300 milliliters was our volume 2. And this was molarity 1. So let's see, M1V1 equals M2V2. And we said in this problem we're looking for volume 1. So we're going to divide a molarity 2. So in this particular problem, molarity 2 we said was 0.5. 0.5. We got to multiply it by volume 2, which is 300 milliliters. And then we got to divide it by molarity 1, which we said was 2 molar, divided by 2 molar, and that was a molarity up there. Okay, you can do your math now. It's going to be 0.5 molarity times 300 divided by 2. You can do your own math and get your calculations there. Number 19. What volume of 5 molar HCl is needed to make this over here? Now this problem's kind of mixed up in that you can't take a low concentration and make it a higher one. So I'm just going to kind of have to fix this because obviously this has the higher molarity. Whatever has the higher molarity, that's going to be molarity 1. And since this is milliliters of molarity 1, that's going to be volume 1. So sorry that this question was set up wrong. This will be molarity 2 because it's the lower molarity. So in this problem, we're looking for volume 2. And to set up the problem, let's see, M1 V1 equals M2 V2. We need to divide, we're looking for volume 2, so we got to divide both sides by M2. That cancels out. So let's see, molarity 1 we said was 6 molar times volume 1. That's going to be 400 milliliters. Oh, ml, label it right, Richard. Divided by, and that molarity 2, and we said molarity 2 was 5 molar. So you're going to do 6 times 400 divided by 5. Your answer will be in milliliters. And then hopefully, probably on the test, you're probably going to have to convert that to liters. So you need to make sure you can do that. Remember, something like 800 milliliters becomes 0.8 liters. Just a nice little reminder for you. Number 20, we've got 10 milliliters of a 5 molar solution, and we need to make 500 milliliters. What's the molarity of the dilute solution? Well, that's going to be molarity 2, which means this is the higher molarity 1. This will be volume 1 because we're talking about 10 milliliters of that. This will be volume 2. We're looking for M2. And so let's see, M1V1 equals M2V2. We got to divide both sides by volume 2 to get molarity 2. And then let's see, we're going to do 10 milliliters times, 10 milliliters times, that was 5. I got the numbers backwards, but there we go. Adds up. It will average out. And we're going to divide by 500 milliliters here. And so now you can do the math on that. Well, I'm going to have to stop right here because my time is running out. Period 6 is about to start. So there you go.